Welcome to Calvin and Math. In this video, we're going to learn how to describe the nature of roots of quadratic equations. So the nature of roots of quadratic equations depend on what we call the discriminant. So the discriminant is given by b squared minus 4ac, where a, b, and c are the coefficients that are found in the standard form of a quadratic equation. That is ax squared plus bx plus c equals 0. So there are three cases that arise. There's a case where the discriminant is less than 0. So when the discriminant is less than 0, then it means that the roots will be distinct and complex. So they say distinct and complex. That is where we get imaginary numbers as the roots. Then there's a second case where the discriminant is equal to 0. So when the discriminant is equal to 0, it means there is one repeated root. So it's a1 repeated root which is real. So it is one repeated root that is real. Then a third case is when the discriminant is greater than 0. So when the discriminant is greater than 0, it means there are two distinct real roots. So it's two distinct real roots. So those are the three cases that arise, and you can use them to describe the nature of the roots of quadratic equations. Let us look at an example to see how this works. So we have 2x squared minus 3x plus 1 is equal to 0. So the first thing to do here is just to determine the value of a. In this case, a is 2, and the value of b is negative 3. And finally, we have the value of c, which is 1. So the discriminant of this is obtained by taking b squared minus 4ac. So we just substitute these values. B is negative 3. So we have negative 3 squared minus 4 times a. A is 2 in our case, times c, which is 1 in this case. So negative 3 squared is 9, minus 4 times 2 times 1, which is 8. So 9 minus 8 is 1. So you can see that the value of the discriminant in this case is 1, and 1 is greater than 0. And we say that when the discriminant is greater than 0, then it means there are two distinct real roots. So in example 2, we have x squared plus 3x plus 4 equals 0. So in this case, a is 1, b is 3, and c is 4. So the discriminant in this case will be b squared. B is 3, so we have 3 squared minus 4 times a. Our a is 1 times c, which is 4. So 3 squared is 9, minus 4 times 1 times 4, that is 16. So that will be negative 7. So negative 7 is less than 0. And we say that when the discriminant is less than 0, then it means that that particular quadratic equation has got two distinct complex roots. So they are distinct and they are complex. Example 3, x squared plus 6x plus 9 is equal to 0. So a in this case is 1, and b is 6, and c is 9. So the discriminant, which is given by b squared minus 4ac, will be, we take b, that is 6, squared minus 4 times a, which is 1, times c, which is 9. So 6 squared is 36, then 4 times 1 times 9 is 36. So the discriminant is 0. So when we say that when the discriminant is 0, it means we have one repeated root. So the nature of the roots of this quadratic equation will be one repeated root that is real. So it is repeated and it is real. So at times you're given an equation that is not in standard form, and you're required to describe the nature of its roots. So what you do, you first of all simplify it to the form ax squared plus bx plus c is equal to 0. So like in this case, we can use FOIL to open up the brackets. So we look at the first terms, that is x and 3x. We multiply them, we get 3x squared plus the outer ones, that is x and negative 1. We get negative x plus the inner one, that is negative 4 and 3x, that is negative 12x. And then we have the last ones, that is negative 4 and negative 1, which is positive 4. So we simplify this by collecting the like terms. So we're going to have 3x squared, then we have minus x minus 12, that is minus 13x, then plus 4 is equal to 0. So we have the equation in the standard form of quadratic equations. So now we can see that a is 3, b is negative 13, and c is 4. So the discriminant will be b squared, that is negative 13 squared, minus 4 times a is 3, times 4, that is c. So negative 13 squared is 169. So we have 169 minus 4 times 3 times 4, which is 48. So when you simplify this, you get 121. So 121 is greater than 0. And you say that when the discriminant is greater than 0, then we have two distinct real roots. Two distinct real roots. Thank you for watching. Kindly subscribe to my channel and see you in the next video.